Lesson 6-1, slope, and in this lesson you'll learn to find the slope of a line given by the coordinates of 2 points on the line. Why is it important? Because you can use slope to describe lines and solve problems involving construction and architecture. And let's take a look at this real-world application in construction. Alan and Mabel Wong bought a lot in San Francisco on which to build a house. The lot is located on a street having an 11% grade. The length of the sidewalk along the lot is 43 feet. City ordinances state that there must be a 5-foot clearance on each side of the house to the property line. The house they would like to build is 32 feet wide. Will they be able to build their house on the lot they bought? So we will solve this in example 4. So this is the scenario that they have. Okay, so their house is on an 11% grade. Okay, and the length of the sidewalk along the lot is 43 feet, and there should be a 5 feet 5 feet clearance on each side of the house from the property line. Okay, and they would like to build a house that's 32 feet wide. We'd like to find out, okay, if they can build their house on the lot they purchased. Okay, so this is a good example of slope. What do you think of when you hear the word slope? You might think of how something slants either uphill or downhill. Suppose you place a ladder against the wall, then you move the base of the ladder out about a foot. What happens to the slant of the ladder? Suppose you move it again. What happens? And observe the pattern. So this is what it means. So you have a ladder against the wall, and then you move the base of the ladder out about a foot. Okay. So every time you move that, okay, base further and further, okay, what happens to the slant of the ladder? Okay. So if you notice, the slant decreases as you move the base farther and farther. Notice that the top of the ladder moves down the wall, okay, when the bottom of the ladder moves out. Okay, as the top moves down the wall, the slant or slope, okay, becomes less steep. If you continued to move the ladder out, eventually it would lie flat on the ground and there would be no slant at all. So the slant that we're talking about in this case is called the slope. Okay, so the steepness of a line representing the ladder is called the slope of a line. It is defined as the ratio of the rise or vertical change to the run or horizontal change. Okay, so basically what it's saying that the ratio or the slope is basically rise over run. When it says it is defined as the ratio of the rise or vertical change to the run or horizontal change, so it's rise over run. As you move from one point of the line to another, the graph at the right shows a line that passes through the origin and the point 5, 4. So you have the origin right here and it passes through 5, 4. Okay, so to be able to find the slope of this line, we want to find the rise and the run. Okay, and if we start from the origin, okay, the rise is the vertical change and the run is the horizontal change. So from the origin, okay, we are going to create find the rise over run, which means that we are going to make sort of a right triangle where we can find this is our run and this is our rise. Okay, so that's what we want to find out, the run and the rise. So let's begin. So from the origin, okay, we find 1, 2, 3, 4, 5 units, okay, for the run. And then from there we go up 1, 2, 3, 4 units for the rise. Okay, and if we go back to our ratio of the slope being rise over run, change in x, sorry, change in y over change in y. So change in y over change in x, I'm sorry. Okay, this would be equal to 4, which is our rise, over 5, which is our run. So the slope of this particular line is 4 over 5. Okay? So the definition of slope, we go now to our definition of slope, which simply means the slope of m. Okay, slope is always designated by the lowercase m of a line is the ratio of the change in the y coordinates to the corresponding change in the x coordinates. Okay, let's take a look at example number 1. Determine the slope of each line. So in letter A, you have this line and you have your rise as 3. Okay, let me change that again. You have your rise as 3. Okay, and your run will be 2. So the slope of this line would be 3 over 2. Okay, so m equals 3 over 2. So in this case, if you look at this one, if you start from one point, if you don't know how the units came about, you always start from one point and create a right triangle when finding the rise and the run. Okay, so you start, let's say you start from 3. Okay, so start from this point, I'm sorry, right here, which is 1 and negative 1. So 1, 2, 3. Every time you go to the left, okay, or every time you go to the, or you go down, that would result in a negative, okay, run or rise. Every time you go to the right, or every time you go up, that will result in a positive run or rise. So let's follow that. So from here we counted 1, 2, 3. That's why you have negative 3. And from negative 3 you went down 1, 2, 3, 4. Okay, so you have a negative 3 over a positive 4. Well, actually, okay, let me do that again. Let me redo that. Okay, okay. So let me correct myself. From that point, you go 1, 2, 3, jumps to the right. So that becomes a positive 3. And you make a 1, 2, 3, 4 jumps down. That becomes a negative 4. So your slope will be 3 over negative 4, or negative 4/3. Now, why is this different? Because the book did it this way. So with the book, this is how they did it. They started from the bottom, this point right here. So 1, 2, 3, 4, positive 4, going up, and then moving to the left. Now you have a negative 3. Okay, so positive 4 over negative 3. But the result will still be the same. Your slope will still be equal to negative 4 over 3. Okay, let's take a look at letter C. In letter C, you have a horizontal line. And if you notice, in a horizontal line, there is no rise. That means that there is no change in y, which is 0. But the change in x would be 2 units right here. So the slope would be equal to 0. In letter D, on the other hand, you don't have a run. So that means this will be change in y will be 3, change in x will be 0. And if you notice in commandment number 1, thou shalt not divide by 0. So in this case, okay, the slope is undefined. There is no slope for this type of line. So if you have a vertical line, you don't have a slope because the slope is undefined. Okay? So knowing all of those, let's analyze the slopes for the graphs in example 1. Okay? The graph, let me just take this out. so we can see what's there. There you go. So let's analyze the slopes in the graphs in example 1. Graph graph A slopes upward from left to right, has a positive slope. So every single time you see a line that's sloping upward, it's always a positive slope. Graph B slopes downward, okay, from left to right and has a negative slope. Graph C is a horizontal line and has a slope of 0. All horizontal lines will have a slope of 0. And graph D is a vertical line and its slope is undefined. Okay? So these observations are true of other lines that have the same characteristics. And since a line is made up of an infinite number of points, you can use any 2 points on a line to find the slope of a line. So we can generalize the definition of a slope for any 2 points of a line. Okay, and this is how we generalize it. So determining the slope of given 2 points, okay, given the coordinates of 2 points, x sub 1 and y sub 1 and x sub 2, y sub 2 on a line, the slope m can be found as follows, again denoted by lowercase m, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, where x sub 1 is not equal to x sub 2. Why? Because that's a restriction. If they're equal, then our denominator will be 0, and we're going back again to commandment number 1. Okay? So this is now the formula for slope. And this one you need to memorize for a very long time, because you will deal with that formula, okay, in other matters in algebra. Okay? So again, we read it as, okay, y, and then the subscript 2 is read as y sub 2, okay, because 2 is called a subscript. Okay? So let's take a look at example number 2. Determine the slope of a line that passes through 2, negative 5, and 7, negative 10. Okay, and there are 2 methods that we can use. Okay, and they're basically the same. So the first thing I would like to tell you, or a big tip, is that you label your points. So let's say let's label our 2 points. Let's label x2 as, 2 as x sub 1, negative 5 as y sub 1, 7 as x sub 2, and negative 10 as y sub 2. Okay? And then after we label them, it's easier to put them in the formula for slope. Okay? So let 2, negative 5, x sub 1, y sub 1, that's what we did, and 7, negative 10, x sub 2, y sub 2. Then we simply write down the formula first, okay, like always, and then we substitute the values, y sub 2, y sub 1, x sub 2, x sub 1, okay, negative 10 minus negative 5, 7 minus 2, and you end up with negative 10 minus negative 5 is the same as negative 5 all over 5, or the slope is equal to 1. Okay? Now let us look at method number 2. In method number 2, we basically switch the values. We make this x sub 1 and y sub 1, and we make this x sub 2 and y sub 2. And let's see what happens. Okay, so in method 2, we do the opposite, 7 and negative 10, x sub 1, y sub 1, to negative 5, x2, y sub 2. Write down the formula again, substitute the values, and if you notice, the slope will be the same. So what do you notice in this one? Since the slope of the line is negative 1, that, as you can see, it does not matter which ordered pair is selected as x sub 1, y sub 1. So you can choose a point and label it x sub 1, y sub 1, and the other should be x sub 2, y sub 2. Okay? All right, let's take a look at example number 3. Before we do that, if you know the slope of a line and the coordinates of one of the points on the line, you can find the coordinates of other points on that line. Okay, so what does that mean? Let's take a look at this example. Example 3, determine the value of r, so that line through r 6 and 10, negative 3 has a slope of negative 3 halves. Okay, so we know one point. We don't know one coordinate of the other point, but we know what the slope is. Okay, so basically this is what we're trying to find out. This one right here. If you have a line and you know the slope and you know one point, you just have to find the other point right there. Okay, so let's start again. We start with the formula. M, or the slope, is equal to y2 minus y sub 1 all over x sub 2 minus x sub 1. Okay, substitute the values that we know. We know that the slope is negative 3 halves. Okay, we also know that negative 3 is your y sub 2. So let's label this again, going back to labeling. X sub 1, y sub 1, x sub 2, y sub 2. And that's the reason why you have negative 3 minus 6 all over 10 minus r. Okay? So from there, we know that this particular equation forms a proportion, and in solving a proportion, we multiply their cross products. Okay, so we simply multiply their cross products right there, and these two right there. Okay, and we end up with negative 3 halves equals negative 9 over 10 minus r. We simply simplify this first, and now we multiply the cross products right there. So we multiply 10r times 3 and negative 9 times 2. So finding the cross products, we do the distributive property, negative 3 plus 3r equals negative 18, and we simply solve for r. Then we add 30 to both sides. Okay, r 3r equals 12, and we divide both sides by 3. R equals 4. So the value of our x coordinate will be 4. Okay, so that means the slope of a line is negative 3 halves, which passes through 2 points, 10, negative 3, and 4, and 6. Okay, and let's take a look at the last example. You can use slopes with other mathematical skills to solve real-world problems like the one presented at the beginning of the lesson. So let's go back to the beginning of the lesson, to the Wong's problem. Refer to the beginning. Okay, look at your book so you don't have to rewind the video. Okay, will the Wongs be able to build their house on their lot? So what do we know? The width of the house and the two 5-foot clearances equal 32 plus 2 times 5, or 42 feet. Thus, horizontal measure between the property lines must be at least 42 feet. Okay, so that means it has to be at least 42 feet. So we can use trigonometric ratio, SOHCAHTOA, to determine if there is an adequate room for the house. A grade of 11% means that the rise is 11 feet, okay, while the run is 100 feet. Okay, we can use this information to find the measure of angle A, and this is actually what it means. Okay, so when you say 11%, that means that the rise is 11 feet and the run is 100 feet. Remember, the grade is 11%. Okay, so that will be the slope, and that's why we have your rise as 11 and your run as 100 feet. Okay, from there we can find the measure of angle A. So if you notice, again, if you review your trigonometric ratios, how is 100 related to angle A? It's adjacent. And how is 11 related to side 11? That side, it's opposite. So that means you're talking about adjacent and opposite side. And if you remember your trigonometric ratio, SOHCAHTOA, okay, opposite and adjacent will give you the tangent ratio, exactly what we have here. So tangent A equals 11 over 100. Okay, tangent A equals 0.11. Okay, and then so the angle of tangent A will be 6.3 degrees. Okay, so we can use the measure of angle A to find the horizontal measure X of the property. Okay, so if you look at this particular uh, drawing right here, so this is 6.3 feet, okay, 6.3 degrees right here, okay, and this is 43 feet. We want to find x feet right there, okay. In doing that, we use the cosine ratio, cosine A. Why? Because 43 feet is the hypotenuse and x feet is the adjacent. Using the cosine ratio, we multiply both sides by 43. 43 times cosine 6.3, and then we end up with x as 42.74. Okay, so the lot is 42.74 feet wide. The housing clearances will fit the 43-foot lot, so the Wongs can build their house on the lot that they bought. Okay? And that's how you solve the problem of the Wongs. And the key word for this particular lesson, the secret word that you need to write down, is Colts, C-O-L-T-S. Thank you for watching.